Hi, this is Jim Bergmann with TruTech Tools, and today we're going to take a look at the Testo 320. The Testo 320 was a replacement for the Testo 327. Done a lot to this instrument as far as upgrades, including a really vibrant color display. And I want to take you through what comes with the kit, how the instrument works, overview some of the highlights of the features, and walk you through a simple combustion test. Okay, what we got here is a 320 printer kit, and the 320 printer kit comes with your printer, paper, extra particulate filters, calibration certificate, and a modular probe assembly that can be removed from the instrument. We have it off right now. And also comes with the USB style charger that's a full-size USB to a mini USB that plugs into the bottom of the instrument. Really nice kit, very similar to the Testo 327 printer kit as far as the parts and accessories. The thing that makes this instrument really unique is the fact that other accessories can be added, like an ambient air probe, or in this case a gas leak detector or CO probe. So we're going to go over some of the accessories that can be added to the 320 and show you sort of how everything works and goes together, and how to navigate the menus. Alright, before we power up the Testo 320, one of the first things we want to do is attach the probe assembly, because the probe assembly is used for the initial zeroing of the instrument. It's going to go out and it's going to measure the stack temperature with the stack thermocouple. So first thing I want to do is pull the dust cover off the bottom of the instrument. Once I get that dust cover off the bottom, what I need to do is attach the probe assembly to the bottom of the instrument itself. Now, the probe assembly on the 320 measures everything. It measures flue gas, draft, and temperature. So I got to make sure that these two gaskets are sealed tight on the bottom of the instrument. There's an arrow that's stamped in the housing here and an arrow that's stamped onto the probe assembly itself. I'm going to line those up arrow to arrow, push that on there, and then the most important part is there's a bayonet clip right here. I want to turn that bayonet clip about 1/8 of an inch till I hear it click, and now I have a positive seal of that probe assembly on the bottom of the instrument. And that's pretty much all you got to do to get that commissioned. Alright, important thing to remember with any combustion analyzer is it needs to be zeroed in fresh air. So we stepped outside here for a minute just to let the instrument go through its initial calibration. I'm going to go ahead and turn the instrument on, press the power key on here. When the instrument powers up, you're going to see, first of all, it's Testo 320. You're going to see the firmware version, which is 1.01, and you're going to see it start going through its warm-up here on the bottom of the display. It's going to go through this a couple of times. We'll see this go through. And as soon as this gets past the bar here, it's going to go to its initial menu, which is right there. We have a few seconds left here in the calibration, which is doing a countdown right here. It's a 30-second warm-up. Once it gets done with that 30-second warm-up, we're going to see the display go back to our measurement screen. 2, 1, 0, and now we're at our measurement screen for analysis. All right. On furnaces like this 90 plus, ideally we would be making our combustion test outdoors at ground level if it exited the home through side penetration. A lot of times though that's not possible, and it terminates to the roof, and we have to drill a hole in the flue pipe in order to do a combustion test, and that's the case of this 90 plus right here. So picking a hole location can be pretty important, and what you don't want to do is you don't want to be too close to the draft inducer. We don't want to drill through this thin plastic, but also just the velocity of the flue gases as they travel up here can cause problems with our static pressure reading in our stack when we go to do the draft reading on the analyzer. So ideally here we want to have about 18 inches of space to give that air time to slow down, so that we read pressure and we're not influenced by the velocity of the gas in the flue pipe itself. This is like this 90 plus have a category 4 vent system, which means it's under positive pressure, which means that we have to make sure that that flue pipe is sealed after we do our combustion test. I found the best way to seal the pipe up is right here with a brass pipe plug. So what I did here is I drilled this pipe plug out, or drilled a hole for this with a very bit, and then all I did was use the pipe plug threads to actually tap the hole. It's soft pipe, it'll go right in there and tap, and this, because it's tapered, provides a real nice positive seal. You can see that tightens up, and now I don't have to worry about that falling out again. I can easily take it in and out every year and have a nice port for combustion testing that I know is sealed, it's not going to leak into the home. I like using the Allen screw simply because the Allen screw is a little bit more tamper-proof than some other types of connections we could use, like a screw thread. Now all I got to do is take my cone assembly in here, which is tapered and threaded into the flue pipe, and I'm all set to do my combustion test. Alright, so now I've got the cone assembly in here. All we got to do is we're going to slide the probe shaft in. We're going to touch the back of the pipe, pull it about halfway out, and then tighten up the set screw here so the probe assembly is locked in for testing. Most atmospheric appliances get the air for combustion from the basement. In this case, we have a 2-pipe 90 plus and we're getting air from outdoors. So in order to get that accurate efficiency reading, we actually have to get the outdoor air temperature, because what we want to actually measure is called the net stack temperature, which is simply the gross stack temperature minus the combustion air inlet temperature. So what we're going to do here is we're going to pull the thermistor out of the bottom of the instrument, and this thermistor comes standard in the 320, and this is simply used to measure the combustion air temperature or the room air temperature that we typically be working in. To get this out, you simply grab it and you pull it. You've got to wiggle it out carefully. You don't want to squeeze it too hard because you can damage the cage assembly around that. Once you pull that out, you can set it in your box. And now I'm going to go ahead, I'm going to plug in the 9797 probe, remote probe. It is keyed. There's a small slot right here that goes towards the bottom. So I'm going to get that lined up towards the bottom. I'm going to plug that in, and now I can measure combustion air temperature right with the analyzer in the to measure the combustion air temperature right in the pipe. So while getting everything set up and shooting a video here, I actually ran the battery on the analyzer to the point of exhaustion. So what I have right now, I just plugged in the USB cord in the bottom of the analyzer. And just a quick note on that, you can actually run the analyzer with the USB connection, and it's a power connection. But what you can't do is you can't run it and charge it simultaneously. So once your battery is exhausted, if you don't have another battery to put in, which a spare battery is an accessory, you can run it off the charger all day, not a problem at all, and then charge it in the evening again. So that's what we're going to be doing on the test. So now I got the analyzer set up, I've got my combustion air probe set up, I drilled a small hole in my flue pipe here, I have that probe mounted in the flue pipe, I have my stack gas set up. I'm going to go ahead and start the furnace up, let it run for a few minutes, then we're going to start a combustion test. Because this is a 90 plus, again, I can't stress enough that you have to have the bottom, the combustion door on the furnace when you're doing testing. We want to make sure that we're pulling air from outside through the intake pipe and not from in our basement. The furnace will operate differently, or could operate differently with that door on or off. It's designed to have the door on in operation, so that's the way we want to do the testing. The furnace has been up and running for a few seconds. It's started, the burner's lit. We typically expect to see high CO light off. That's very common for 90 plus furnaces. There's really no need to expose the analyzer to that high CO reading, so I'm going to go ahead, now that it's lit, I'm going to go ahead and start the combustion test. Go ahead and start in the analyzer. You'll see right away it's going to register that higher stack temperature because it's in the stack gas. And I'm going to zoom in a little bit closer here in a second, and I'm going to walk you through some of the readings. I always get asked, well, what are you looking for when you do a combustion test? And I want to start off with these first 4 readings on the analyzer. I've got stack temperature, O2, CO, and CO air free. And these are probably, in my opinion, the most important readings that the analyzer makes, because they're the actual readings that are being measured. Everything else, aside from the first 3 measurements, is calculated on the analyzer. Now, you can see here, my stack temperature is running at 124. And you can see it's bouncing around between 0.3, 0.7, 0.5. This is a stable stack temperature. This is the point at which we consider the furnace at steady state. And this is where we're going to start actually looking at our combustion and seeing how things are operating and making sure that other things are not going out of kilter. Now, you can see I got 7.8% O2. Pretty typical for a 90 plus furnace. I want to see that somewhere between 5 and 7% oxygen. I'm at 28 parts per million CO. I'm at 43 parts per million CO air free. My raw CO number I want to pay attention to, because I want to make sure that that number is stable. I want to make sure that it's not climbing. If our CO is climbing, our O2 is dropping, right? That can be an indication that we have a combustion dilution ventilation problem. Also on my CO air free here, I want to make sure that that stays under 100 parts per million. If that's over 100 parts per million, we have a furnace that's that is a dangerous furnace that we want to get repaired. If we take a look at the efficiency numbers now, you can see we're at about 89% efficient. This is a 90 plus furnace, and it is a true 90 plus. It's not a 95, so it's running right about where it should be. If I scroll down one, you'll see that I can see my gross efficiency and my net. Now, this furnace is a condensing furnace, but we are not very far into the condensing range at all. On a 95% efficient furnace, obviously, you know, the net would still be around this 89%, but our gross efficiency would be much higher. So if we were to measure the volume of condensate coming out of the trap on this, it would be fairly negligible. But it is condensing, and it is a condensing appliance. If I scroll down again here, on line 8, I have excess air. This appliance I want to see run with about 50% excess air. That gives me enough excess air to assure safe combustion for a residential appliance. That could run as low as 30% on a 95% efficient furnace because they don't want the excess air to dilute the flue gases and you know, raise the dew point temperature of the flue gas. But in this case, 50% is exactly what I want to see. I'm real happy with that number right there. Scroll down again, I can see the dew point of my flue gas. You can see it's 125 degrees. That should be exactly the same. I'm going to scroll back up here for just a second as my stack temperature. So my stack temperature is 125.5. Scroll back down. My dew point temperature is 125.5, same as that was. You can see it bouncing around right there. The reason the dew point temperature and the stack temperature are the same is because, again, I'm in the condensing mode. Scroll down again, I have CO2. If you're used to looking at CO2, 7.34% CO2 is pretty typical for this type of appliance. Scroll down again, I have my inches H2O. If I measure differential pressure, like a gas pressure, I want to record that on here. I could have that on the display. It's dashed because I haven't measured it. Scroll down again, I have my ambient temperature. And this is tied to the appliance, so I think we're reading the temperature of the instrument. Scroll back down again, I have gross efficiency, net, and we can go back up to the top again. So let's get this back up to, let's see, back up to the top, and we're back at line 1. Every line down here is numbered, so what it does is it loops around. So right now, if I scroll down to the bottom here, 9, 10, 11, 12, I have at the 12th line, that's my ambient temperature. If I hit down one more time, I'm going to scroll back up to 1. All right, every time you hit the down arrow, it goes down one space on the display. I'm going to go ahead and stop the flue gas test, and I'm going to show you a little bit about the flue gas matrix because I think it's an interesting feature of the Testo 320. So I'm going to go ahead and push the stop key here, and I'm going to hit escape one time to get back a menu to the flue gas analysis. I'm going to hit options here and go down to fuels and test options and hit OK. Under natural gas now, I just want to hit the options key, and this takes me into combustion types. And what this allows me to do is set up for different appliances. So I'm going to adjust my first combustion type. On this 90 plus, I typically would not want to see an O2 above 9%, so I'm going to go ahead and edit that, and I'm going to take this up to 9% on the excess air, which would be probably around 75% excess air if I'm thinking right off the top of my head. I'm going to hit OK. And I want my CO to be optimized at 100 parts per million. So I'm going to hit the up key once here, that's 1. I'll take these down to 0. I might probably bypass it. 0 and 0, hit OK. So now I'm optimized for this combustion zone. Maximum O2 I want to see is 9%, CO 100%, and I'm going to hit finished. Now I'm going to go back into testing, natural gas OK, and flue gas OK, and now I'm back in and I'm going to start my combustion test again, and you know, nothing's changed here, but I'm going to go into options and I'm going to go into my flue gas matrix now. When I go into the flue gas matrix, you can see that it's optimized for my CO says it's optimized. It goes 0 to 200 here, right? So the top end of the range is 100. My O2, my top of the range is 9%. I'm in the green zone here, which indicates that I'm in the combustion zone I want to be in. I have good combustion. I have thumbs up on both. CO is 25, O2 is 7.9%, so I'm in the safe zone. While we're in the safe zone, as far as CO and O2 are concerned, you do have to keep in mind that we do want to maintain about 50% excess air on this 90% efficient appliance. So don't let the fact that this green zone goes all the way down to 0% fool you, because we want to make sure that we still have enough excess air for safe combustion and enough excess air that as the appliance gets dirty, it doesn't start to make CO. just so you know what's going on in the matrix here, I didn't really cover it in the beginning. I want to just make sure you get this here. Up in the exclamation marks means we're getting to the high CO range. Over here into the dollar signs means that we're getting into the high cost range to operate. So over here in the balance point right here, we're at the optimal cost and we're in the optimal safety zone. The further down we get on the CO side, the better off we are. The further in we get on the O2 line, the better off we are, down till we get to the point where we get probably down below 4% O2, which means we're not going to have enough excess air for safe combustion for a residential appliance. We're talking a commercial burner, we might run that down as low as 10% excess air in ideal, where we have an application we're going to test it a lot and keep on top of it. But for a residential appliance, 50% excess air is pretty typical where we want to run. If we're up here in the infinity symbol zones, I'm not sure what that symbol is for. Obviously we have too much air and we have too much CO, and this is not the area at all we want to be into. So we can go ahead and stop measurement there, and you get an idea of now how the analyzer works in that range. When we stopped it, you can see here it's showing us that we have the checkered flag here saying that the appliance is operating the way that we want it to operate. Hopefully you got a little bit of an insight into the Testo 320. Just a couple more features I want to go over before we close up the video here. One is the water trap on the side here. Testo did integrate the trap into the analyzer. There are some advantages to that. Number one is we can have a much shorter probe assembly, and the shorter probe assembly means we're going to get a faster response reading to the flue gases if we're trying to watch like a peak CO reading on the analyzer. The integrated water trap, you empty it by simply pulling up the plug on the top here. You don't want to pull it all the way out, just pull it so it's loose here. Turn the instrument upside down, shake it, and you can see the water coming out there. So that's positive proof we're well into the condensing range. And I want to go ahead and close that up by just pushing it on the top again. If you ever have your analyzer reading a high O2 reading and it's not a leak here at your probe, make sure that you push down the water trap seal all the way because it can pull in air there. A couple other nice features on the instrument on the 320 are, it does have field replaceable sensors. So a couple screws in the back, pull that out. You can pop a new O2 or CO sensor right in the instrument yourself in a few minutes. The 320 also has firmware that can be upgraded by the user. Testo, if you go to the Testo download site, the download center, if there's a firmware upgrade, you simply upgrade it through the USB port here. It goes into a boot mode. The directions are right on the website. You go into a boot mode and you simply drag and drop the firmware right into the instrument, and it'll load the firmware, the new firmware for you, and it's good to go. So the 320 has really been well thought out, and I'm sure we're going to see some more features of this instrument as it grows. It's a new instrument for Testo. They tend to improve some things over time. So I'm sure we're going to see a few firmware upgrades and things you can do to the instrument. We do have also a bunch of different probes that are available for this. One of the ones I do like is the CO probe. The CO probe plugs right in here, and you can actually measure ambient CO while you're combustion testing. A little bit on the pricey side, but if you want to record the ambient CO reading while you're doing your combustion testing, it's really handy. Also, you can unplug the flue gas probe and plug into the bottom of this a differential pressure port. The 320 does have differential pressure, so you can see there's a differential pressure port on the bottom of the instrument. So this is the negative side, or this is the positive side of the differential pressure port. The negative side's built in here, and you do want to make sure that you use the accessory. Don't just slide a hose over top of the probe assembly to measure pressure here, because you got to remember, if you do that, you're going to pressurize the flue gas path and the manometer port. You don't want to do that. The accessory probe that snaps on here isolates off the flue gas path so that we only pressurize the pressure transducer and we don't take a chance at making an internal leak inside the instrument. So again, hope you got a little bit out of this video. This is Jim Bergmann with TruTech Tools. Thanks a lot for watching.